Hey everybody, today you can see the title on the screen. We're going to factor simple trinomials, but today we're talking about day 2. So as you are working your way through, I'm hoping that we've been comfortable to be able to go through and just factor some simple trinomials and get comfortable with the mechanics of that process. Two numbers that multiply, two numbers that add, two numbers that multiply, two numbers that add, when we see the pattern that you see in green. Our squared something, our single something, and a constant. Today, what we're going to do is we're going to get a little more practice working through that process, and then we're going to stretch you a little bit. We're going to see some instances where this could be helpful. Okay, let's jump right in. What you see on the screen right now, there are 4 trinomials for you to go through and try to factor. I think these 4 problems give you a good little practice quiz, like a good gauge. Did you pick up what you needed to from the previous day? So what I want you to do is to try to tackle those 4 as if they were a written evaluation. You're going to pause the video, you're going to do it on your own, and then we'll come back in the end and we'll see how well we did. Okay, pause it now. Okay, we are back. So as you take a look at those 4, your gauge isn't just, did you get the correct solution to them, but also, how much hesitancy did you have as you worked your way through? Like, did you hesitate a lot? Were you unsure? Did we kind of get a feeling like we fluked out an answer? All of those things are going to help us to gauge whether we've got a good grasp of being able to factor these trinomials. So let's check. You work your way through on that first one, and we're looking for 2 numbers that multiply to give -10 and add to give -3. And so if I go through my numbers that multiply, there's my factors of 10. I get 5 and 2, and 5 and 2 are 3 apart. I need it to give me a -3, which means I need a -5 and a +2. And there we go. So hopefully we matched up. That will be the last time that I ever write that in the top right corner. I think we should be good to be able to keep those numbers in our head. Okay, let's keep it going. You take a look at B, x squared minus 7x plus 12, squared something, single something, constant. I need 2 numbers that multiply to give 12 and add to give -7. You take a quick peek on that, and you match up with the constant at the end, but we do not match up with the constant in the middle, the coefficient on that x, I should say. Be careful, we need a -7. So I need to make sure that I had a -4 and a -3. Now it matches up with both. Okay, we take a quick look at C. I'm going to argue I think C is your trap problem. I think it's an expression that becomes an absolute trap. Because we look at it and we go, hey, 2 numbers multiply to give 6 and add to give 5, 3 and 2, and we come in so easy on 3 and 2, that we may be tempted to go, well, I need a -5, so there's a -3 and a -2. But we're wrong. You take a peek. If you were to expand that, your negative times your negative does not give you a negative. So we got to be careful. Instead, 2 numbers that multiply to give 6 and add to give 5 can be 6 and 1. I need a -5, so that means I need a -6 and a +1, and there we go. Now you get a quick confirmation when you re-expand, you do get back to the original. And on question D. D is the one that I think, is it giving you a good gauge? Do you have your factoring checklist being developed? So take a look at D. The first thing I always look for is a greatest common factor. And do I have a common factor in all 3 of those terms? I do. I have a common factor of 2. And so when I factor out a 2 from all of those terms, I'm left with that trinomial. And notice it is a simple trinomial. So now I'm looking to see, can I factor further? And I do have 2 numbers that multiply to give 9 and add to give 10. That's a 9 and a 1. I got to make sure they're both negative to get back to that -10. Okay, take a look at the screen in its entirety. And I'm hoping that that little warm-up worked well for you. I'm hoping you were able to go through, get the correct orange expressions, but also that there was very little hesitancy, that you were pretty comfortable with that stuff. If you are, that's giving you a good gauge and giving you good feedback. You're good with the stuff from last day. So what I want to do now, and for the rest of the day, is I want to take the theory we talked about last day, and I want to start to stretch it a little bit. Okay, I want us to take what we know and we're fairly grounded with, and I want to stretch it. So the problems we're going to look at are going to be a little more complex. Let's jump right in. I want you to take a look at E. Because I'm going to argue to you, E should feel like a stumper. You take a look at E, and something might be jumping out at you. And I mean jumping out at you. I'm going to highlight it in the question. I think that 4 may be something that you look at and go, wait a sec. Well, we've never dealt with an exponent 4 on an expression before. And I'm going to say stop for a second. That the expression in E is what we've been dealing with the last couple days. I know it's really hard to see it, but I'm going to scan my way across. I have a single something in my middle term as an x squared. Now you're going to look at me and go like, but wait, that's not a single something, it's a squared something. But it could be viewed as a single something if I notice that my first term is it squared. Notice x squared gives me x to the 4th. So I'm going to write down this problem in a different form. You would never have to do this as part of your solution, but I think it's going to help us to see this is actually an expression we've worked at last day. If I view that x to the 4th as x squared all squared, there's my x to the 4th. That is my gold. Then I just copy out the rest of the expression. Then I'm hoping we recognize that this is one of those 2 variable trinomials that we dealt with last time. Now maybe you can see that I have a squared something, a single something, and none of them. And then I have the opposite with my other variable. I have no y's, 1 y, 2 of them, squared them. So this is a hidden simple trinomial. Okay, how can we factor it? Well, I think the big puzzle for a lot of us is going to be what goes at the front of both brackets. Well, last time it was always, hey, I put an X at the front of both brackets, or I put an A at the front of both brackets, or I put an M, or whatever. But now the key is for us to take a look back and say, what are we squaring? What is the single something? And if you take a peek in what I've underlined in blue, it's x squareds this time. So at the front of both brackets, I need an x squared because an x squared times an x squared gets me back to the x to the 4th. Okay, it was a simple trinomial. So I'm looking for 2 numbers that multiply to give 15 and add to give 8. Hopefully we come in pretty quickly on a 5 and a 3. So I could have a 5 and a 3. But to ensure that I get my y squareds in there, I need both of those to be a y. There we go. There's my factored form. Now, I just want to highlight for you one quick thing when we re-expand to check. If I took my x squared and I multiply it by that for my outsides, I can see I'm going to get a 3x squared y. And you'll notice, if you look back up in the original equation, you're getting x squared y's, what we need for our middle term. You get a little confirmation on your insides. There is another 5x squared y's. And now you feel really confident that we factored that expression correctly. Nice. Okay, I want to leave you with a moment to give F a shot. Okay, I want you to try F. Pause the video now. Okay, we're back. So we take a look. First thing I always look for is a common factor, and I notice that my greatest common factor happens to be 8. That an 8 divides evenly into all 3 terms. So if I factor that out, then I come in on that expression. Okay, is that fully factored? We got to take one more peek inside our brackets. Could we factor that trinomial further? And yes, we can. We see our variable pattern, a squared something, single something, none of them, and then none of them, one of them, two of them. So we are looking for 2 numbers that multiply to give 5 and add to give 4. Well, that would be a -5 and a +1. You'll notice if you re-expand that, we're missing all of our b's. So we need to make sure to include our b's at the end of each bracket. Do a quick check. Notice your outsides give you 1b, your insides give you -5b. That gets us back to our -4ab. Okay, I hope we're doing well. I hope we can see that really this is just stuff that we've been dealing with for the last day. Maybe it just looks a little different. Okay, we're going to keep it going. Some more problem solving. I'd like you to take a look at G and H. And this is a moment where we get a chance to really try to steal some problem solving practice. So I would like you to go ahead and try to tackle G and H on your own. Okay, I want you to pause the video now. Okay, we're back. So you take a look at G, and it's not that this is a horrible decision, but I'm going to argue to you, sometimes it's going to lead you down a bad path. And it'll actually create a situation that you won't have the means to be able to get your way out of. If you recall, factoring is the opposite of expanding. And so I just really hope that I didn't have anybody that did that. Expanded that in. Now, in this instance, we now go through and try to go, oh, wait a second. So now if I try to collect some stuff, I actually don't have anything that collects. I've got an a squared term and a b squared term, no other squared terms. I've got a single a and a single b, no a other b terms. And I'm sitting there looking going, oh, shoot, I created an instance that I can't get out of. So the advice I gave to you last time, when given the instruction to factor, don't expand. Fight the urge. Fight the urge. So what do we do then if we can't expand that? Well, I want to draw to your attention that question G, that expression, that is a simple trinomial. Notice you have a squared something, a single something, and none of them. It's a bit of a hidden simple trinomial. Okay, if we are struggling to see that as a hidden trinomial, then I'm going to go ahead and do something that I would suggest to you that if you are struggling to see certain expressions, maybe try this strategy. It's just called substitution. That what I might do is I might say that I'm going to let x, just some symbol, represent, equal, that expression that pops up a couple times, that a minus b. I see a minus b pop up twice in that expression, and I'm going to replace the a minus b, the 2-term expression, with a 1-term expression, x. Now, I said that I was going to let some symbol. Just be very careful. Don't, if you were going through, let a equal a minus b. Because now that gets confusing. I'm using a variable within the expression. Or let b equal, same issue. So when I picked x, I just wanted to pick something different. Look what happens when I now replace all of my a minus b's with an x. And you see that you actually have a simple trinomial. Okay, I'm going to pick up the pace here a little bit. If you took that blue, then you should be looking to go through and say, okay, that is now equal to two numbers that multiply to give 10 and add to give 7, an x plus 5 and an x plus 2. Here's the issue. I never asked you to factor an expression that had x's in it. You chose to put those x's in there. We got to get rid of those x's. So now you would have to resubstitute that you were going to sub in an x, 4x, an a minus b. And finally, you come in on, okay, a minus b plus 5 times a minus b plus 2. Okay, what you see in blue, that is called substitution, and that can be a really useful strategy if you want to go through and change the way an expression looks. If you see an expression that pops up over and over, like our a minus b did, well, then you could sub in something simpler to clean up the expression. Okay, I want you to be able to factor the expression in G, though, without showing me any of the blue. I want you to give me just straight that final line in gold. Okay, I'm going to erase that entire solution. If we take a look at the very beginning and we recognize, hey, I've got a squared something and I've got a single something and I have a constant and I've been asked to factor, then that is a simple trinomial. I am looking for two numbers that multiply to give 10 and add to give a positive 7. Okay, we've got our 5 and our 2. So if I went to create those factors, I should be pretty confident to finish off one of those factors with a positive 5 and a positive 2. Okay, what goes at the front of both brackets? Well, what was squared? What was your single something? Look at the expressions that I've underlined in blue. And I just want to get rid of that last underline. Look at the expressions I've underlined in blue. So at the front of both brackets then, I could go straight to an a minus b, and I come right in on that expression. What goes at the front of both brackets? A minus b. What goes at the end of your brackets? There's your plus 5 and your plus 2, and you are now fully factored. Okay, there is an instance, though, that we lose something in this problem. Our problem becomes to re-expand my gold brackets to check and see if I get back to the original. It's not going to be so easy. Because my original is not fully simplified, when I expand those brackets and I start to go, okay, I'm going to take that a and multiply it into everything, then I get an a squared minus an ab plus a 2a. Now I'm going to take my b's and I minus an ab plus a b squared minus a 2, and so on and so on. You can see you're not going to get the exact same expression you have in the original, at least with respect to how it looks. So we lose a little bit on our check. That means we have to be very confident in how we factor. So I'm just going to get rid of all that green mess, and hopefully we're good on the gold. Okay, I think we get a moment to go ahead and try H again. So let's pause the video. Okay, we're back. I think H should have been a bit of a step back from G. I think G is a harder expression. You take a look in H, well, now we've got to the 6th, our first term, x to the 6th. And now I want to highlight something to you. We've started dealing with simple trinomials that looked like something like this. And I'll just put my C. I don't even care about the coefficient in my middle term. Let's just talk about that. Well, then, today, in problem E, we stretched that into an x to the 4th with some x squareds and then something else on at the end. I don't even care what's on the end. There may be a little bit of a pattern to you here that we could draw some attention to. Do you notice that the exponent I have on my middle term is always half the exponent on my leading term? I'll write in the 1 just so we can explicitly see it. It's always half. And so if it is half, it's actually a simple trinomial. It's just a little hidden. So let's take a look back at h. You take a look at h and you recognize, hey, that exponent 3 is half of my exponent 6. I can factor that like a simple trinomial. Okay, two numbers that multiply to give 18 and add to give negative 11. Well, I hope that we're good on negative 9 and negative 2. And now you're trying to sit there and say, okay, well, what would go at the front of both brackets? What was my squared something? What was my single something? And you guys come in on that. If you got down to that, then that is great. But maybe in the blue and the green off on the right, we just drew your attention to another way to recognize trinomials. Okay, we're going to keep it going with problems for today. So I want you to take a look at the two problems you see on the screen now, and same thing as usual. I want you to go ahead and give them a try first. Okay, I think we're building up enough instinct to be able to problem solve pretty decently. Okay, I want you to try them on your own. Pause the video now. Okay, we're back. So I am hoping that given our last problem, or one of our last problems, that you take a peek and see that 2m plus 1 pop up in a couple spots. And maybe that drove you towards substitution, or at least viewing it. I'm really hoping that nobody went through and tried to expand those brackets, remembering expanding is the opposite of factoring, so don't go in the opposite direction. But if we can recognize those two underlined values, then really what we have is a squared something, a single something, and none of them. And so maybe we can go through and we can factor that. We are actually looking for two numbers that multiply to give negative 8 and add to give negative 2. And I am hoping that we can see that as a negative 4 and a positive 2. So we can go ahead and factor. What is going to go at the front of both brackets? Well, what is my squared something? What is my single something? That is a 2m plus 1. So in that first bracket, I might have had my 2m plus 1, then my minus 4. My other bracket would start with a 2m plus 1, and then my positive 2. Okay, if you got to that point, outstanding. What I just need to do is make sure we're good on a little bit of cleanup. If you look inside your individual factors, you're going to notice they're unsimplified. And so what we can do is we can actually clean those up a little bit. Look inside that first set of brackets and you'll notice that we can collect like terms. Then take a look inside those second brackets, we can do the same, and we get down to there. So hopefully not too bad, and hopefully you were pretty comfortable to be able to go through and recognize that trinomial. Okay, let's take a look at J. You take a look at J, and I'm hoping we're taking a look at a similar sort of pattern. Well, this is a little bit different. How many terms do I have? I have 2. I'm looking for a common factor. I don't see a common factor. And maybe we take a peek at it and we go, oh, well, I don't know what to try on J. And so you bail out and you say, well, at least I can expand. I want to walk through what's going to happen with that expanding, and I want to provide to you two different solutions. If we did choose to expand those brackets, we just need to recognize that we are going farther away from where we're being asked to get to. Well, we can still get to our endpoint potentially. And what you'll notice is when you go through and expand those brackets and collect like terms, you're going to end up getting to that. Of which that is a simple trinomial with two numbers that multiply to give 16 and add to give negative 10. That would be a negative 8 and a negative 2. You eventually did factor. So the act of expanding doesn't mean that we will always create a scenario where we cannot recover. No. But it did mean that I went the opposite direction of where I was trying to get to. Instead, I want to walk through that one a different way. And I'm going to put down an or in between. That when I take a peek at that expression in J, even though I don't see something that repeats, maybe I could make it look like I. And if you recall from last day, there could be some times where we could look at that and say, well, what if my first term was squared and then I had 0 of those? And then my minus 9. That maybe I could view that expression as, hey, two numbers that multiply to give 9 and add to give 0. Now, I never need to see that line, ever. But maybe that gives you a way to be able to factor, hey, what about a positive 3 and a negative 3? Well, if you take a peek, if I was to re-expand that, x minus 5 times x minus 5 gets me back to x minus 5 squared. And then a positive 3 and a negative 3 gets me back to negative 9. And if I expanded my blue times my green, there is a negative 3 x minus 5s and a positive 3 x minus 5s. So it would get me back to 0. You take a peek at what we just wrote down in orange, and there I factored right away. So I'm just going to go through and delete that arrow up above. Okay, why do I think that's better? Well, because now at least I'm going directly to what I'm looking for. And if I collect what's on the inside of my brackets, you'll notice we come in on the same factors. If I do not have to write down that first line, I would argue to you, I think that orange solution is a better solution. Okay, don't fret on question J. We're going to get a lot more experience with J, and we're going to actually start to think about it in a different way. But I want to keep playing through on some problems. In problem 2, I actually want to change the scenario. I'm assuming that we are all pretty decent at being able to factor simple trinomials. We're good when they're kind of basic ones, straight ahead, or some of the ones we've been looking at today where they've been kind of hidden with some other expressions. So let's take a look at question 2 and examine something a little different. I would like you to find all possible k values such that each trinomial can be factored over the integers. Okay, such that each trinomial can be factored over the integers. Now, that instruction, I imagine, is a little confusing. So what I'm going to say is, for right now, I'll explain it later, but for right now, I want you to imagine that that question just said, find all possible k values so that each trinomial can be factored. Factor it the way you think factoring means. And we'll see what we can come up with. Okay, this is a great opportunity for some problem solving. So just try problem A on your own. Okay, what could be the possible k values that we could have so that we could factor that expression? Okay, give it a shot on your own. Pause it now. Okay, we're back. And if we were to take a look at that and say, I need x squared plus something x plus 15 to be factorable, then really what we're looking for is the beginnings of our little algorithm, our process. You would look at that expression and you would hopefully say, well, if I was going to factor it, then I'm looking for two numbers that multiply to give 15 and add to give k. Well, the two numbers that multiply to give 15 is a nice easy start. Add to give k, that's the problem solving. So let's take a peek at it. I have options. Because I don't know what k is, I don't have the second part of that questioning, that process, to nail it down to one possibility. Really what that says is I have two numbers that multiply to give 15 and add to give something. Well, what could that something be? Well, let's look at our what could multiply to 15 as options. Okay, well, we've got two options. I could look at that as a 3 and a 5. Nice. But we could also jump in pretty quickly and say, hey, what about a 15 and a 1? Okay, I'm going to tell you there are two more options, two more possibilities. Can you think about what they could be? Take a look at that first option we wrote down in green, my 3 times 5. It could have also been negative 3 times negative 5. Yes, don't forget about your negatives. But then same thing with the 15 and the 1. Maybe that was a negative 15 and a negative 1. Okay, well, if those green possibilities are all my possibilities that I could have with integers, then if those were the case, what k values would they produce? So if I was to just say, like, well, what if my factors were the first possibility? Like, that's where what if it was 3 and 5? Well, then if I was to expand those brackets right now, I would find out that I get my x squared plus an 8x plus a 15. I just found out that my k would be 8. I just found a possible k value that makes that factorable with integers. Okay, I'm going to erase all of that because that first possibility right there gave me a k value of 8. And I'm hoping we can see how we could get down to our other values. My next possibility in here would give me a k value of 16. My next possibility in here would give me a k value of negative 8. And my last possibility would give me a k value of negative 16. And so I find I get 4 k values. Now, you would never write those 4 down that way because there's a better way to communicate it. And what I'm going to do is I'm just going to get rid of all of those and express it the best way. That if we see those 4 possible green values, then we could just say that k could be plus or minus 8 as a possibility, or plus or minus 16 as a possibility. Don't write a positive 8 and a negative 8 separated. Shorten it up. It's a better way to communicate it, plus or minus. Okay, there you go. There is your answer to problem 2. Okay, now I got to talk about what that whole over the integers means. Can you take a look at my green list of possible numbers that multiply to give 15? I actually have infinitely many numbers that would multiply to give 15. Now, you might be sitting there going like, what do you mean infinitely many? And I'm like, sure. 2 multiplies to give 15. I would multiply that by 15 over 2. Now, some of you guys are going to be decimal junkies, and you're going to look at that 15 over 2 and go, oh, yeah, 7.5. 2 times 7.5. Like, maybe that's the way you think about it. But notice, those 2 values would multiply to give 15. But do you notice that 15 halves or 7.5 are not integers? That's what the problem means when it says factored over the integers. It means that you can only have integer factors. If I didn't write that, then there are infinitely many answers. Like, again, you might look at it and go, infinitely many? Like, no, like 2 and 7.5 makes sense. And I go, yeah, but like, what about 4 and 15 fourths? Like, I could multiply that any way I want. What about 7 and 15 sevenths? Like, notice, if I was to take that last one I just wrote down, 7 times 15 sevenths, well, then I can cross-reduce. My 7s divide out, and I get back to 15. Yeah, the number I'm looking for. So without saying over the integers, then I'm hoping you can see you could go on forever. So when we make reference to over the integers, that's all we're talking about. You need to have integer factors. Okay, I think you have a chance now to try problem B on your own. Okay, pause the video now. Okay, we're back. So now our eyes should be going to that negative 12 on the end. You are looking for two numbers that are multiplying to give negative 12. And I'm hoping that you notice that when they're multiplying to give a negative, that just means my two factors have to be different signs. So like we learned in problem A, oh wait, don't forget about negatives. When I'm now trying to think of a list, I'm now applying a positive or negative to either of them. So for an example, maybe we take a look at two numbers that multiply to give 12 and you go, hey, well, 4 and 3. Well, clearly 4 and 3 give a positive 12, not a negative 12. So one of those factors has to be negative, not both. But that also means right away, maybe I could come up with that list. Okay, could I extend my list? Well, then I have 6 and 2. One of them has to be negative, or the other one. Or I could have 12 and 1. One of them has to be negative, or the other one. And what that can allow me to do is to kind of come up with some quick sums between the two. Take a look at the first two that both include our 4s and 3s. If I put a negative 4 and a positive 3 together, I get a negative 1. But if I put a positive 4 and a negative 3 together, I get a positive 1. And I can come up with my plus or minus 1 right away. Okay, go pretty quick through the other one. Well, 6 and 2, they are 4 apart. So that could either be a positive 4 or a negative 4. Negative 12 and 1, 12 and 1 are 11 apart. So that's either going to give me a positive 11 or a negative 11. So you see where you can combine all those values in one go, and maybe looking back now on the solution to A, you could see how you could get a plus or minus 8 and a plus or minus 16 a little quicker. So what is my solution then for B? My K value is plus or minus 1, plus or minus 4, or plus or minus 11. And I'm just going to get rid of all of that other blue in there so we do not confuse that with our solution. Nice. Okay, a little bit of problem-solving question now. Now that one acts like an application question. You've seen one, you've walked through it. Let's make sure we're comfortable with it. Okay, I want to jump into another problem. So this is going to be our last problem for the day. I want you to give the problem a read that you see on your screen, and I want you to give it a shot on your own. Okay, let's pause the video now. Okay, we're back. So the problem said the area of a rectangle can be represented by x squared plus 6x minus 16. Find expressions to represent the dimensions. So let's just say that I was stumbling my way through this and I said, okay, well, the problem says the area of a rectangle. So there's my rectangle. The problem does say area of a rectangle. And so I would know to calculate the area of that rectangle, I have to take one dimension and multiply it by the other, the length by the width. So if I need to find expressions to represent that and the area of that rectangle is that, then what I really want to do is I want to take that area and I want to write it as something times something. If I can write it as something times something, then I will have it as length times width, or one dimension times the other. And so if I need to take that green expression and put a multiply back in there, that means I need to factor it. So pretty quickly, I should be okay to say two numbers that multiply to give 16, add to give 6. That would be a positive 8 and a negative 2. Now, the question says, find expressions to represent the dimensions. So you would be okay to say the dimensions are, I think for me, I'm going to label them on the diagram just so we get a sense of it. If my two dimensions would be x plus 8 and x minus 2, I hope we're good that x plus 8 will always be larger than x minus 2, regardless of what x is. I'm taking x and I'm adding 8 to it versus subtracting 2 from it. So if I was to label it on the diagram, the longer side must be x plus 8 and the shorter side x minus 2. Now, that's not really needed within the problem, but it's something important for us to consider. If I have my green, just make sure you don't stop there. Like the question does say find expressions to represent the dimensions. I would expect to see a therefore x plus 8 and x minus 2 are the, and that is really messy. Okay, you know how much spelling drives me nuts, especially when the problem or the word is in the problem itself. There we go. X plus 8 and x minus 2 are the dimensions. Nice. Okay, I said this was our last problem, well, but it has a part B to it. So let's just take a look at the part B. For part B, the question says, if x equals 12 meters, find the dimensions. So I want to highlight again, my two dimensions were x plus 8 and x minus 2. So those become expressions for the dimensions. Now what part B is telling me is, if I know what that x value is, now I need to find the dimensions. So when we're given the x value, can you give us the actual dimensions of that, not just a generic expression? And so what could I do? Well, I could sub in an x value of 12. And therefore, my actual dimensions become 12 plus 8 and 12 minus 2. So we clean it up. That gives us a 20 by 10. The only thing missing in that problem now is make sure we put on our units. Units matter. 20 meters is very different than 20 kilometers. So let's make sure that we put on our units and you are good. You would not need a big fluffy therefore statement there. I think if the question says, if x equals 12 meters, find the dimensions, your response is 20 meters by 10 meters. If the person's response to you is, what, I don't understand, I think that's their problem. I think you've clearly explained everything in gold. Okay, there you guys go. So what we did today was we kind of took the theory that we learned last time with how do we factor. We got a little extra experience factoring some straightforward simple trinomials. We then stretched it into some uglier ones where you kind of had to find your way through some hidden trinomials. And then we finish it off with a couple small little application problems. Okay, your job. Continue to make factoring simple trinomials as automatic as you can and make sure that we get some practice and working with some of that application stuff. Okay, your job, jump in and get some practice. Best of luck.